started on today's notes over algebraic proofs. This is your first lesson over proofs in general. You often hear people say, prove it. What does that mean? It means whatever you've said, whatever you've concluded, you've got to give examples. You've got to back it up. Why is what you said true? A proof in math is an argument that uses logic, properties, definitions, and previously proven statements to show that a conclusion is true. We're going to be using a two-column proof, which is a table showing numbered statements and corresponding reasons to organize the argument into a logical order. I've got some helpful tips here that you can refer to throughout today's lesson, but I'm going to be repeating all of these helpful tips throughout all of the examples that we're going to be working on. Essentially, when you solve an algebraic equation, that means you solve for the value of the variable, you're writing an algebraic proof. I'm going to show you what that looks like as a two-column proof in today's lesson. In number 1, you're given the algebraic equation 4x minus 3 equals 13, and you're asked to prove that x equals 4. Okay, well, when I write out the process, that's essentially a proof. So let's solve it. 4x minus 3 equals 13. I'm going to highlight that first equation, that first step, in yellow. And when I solve for the value of the variable, it's just a two-step equation. I'm going to add 3 to both sides. I'm going to highlight that step in a different color. And when I do that, it eliminates the 3 from the left, and then 13 plus 3, is 16. So I get 4x equals 16. What I'm doing is every step that has an equal sign, I'm highlighting in yellow. The steps in between, which is what I did to get to that next step, I'm highlighting in pink. So now I've got 4x equals 16. I need to get the variable all by itself. I'm going to divide both sides by 4, and I get x equals 4. In a two-column proof, what you are given will always be the first statement with given as the reason. You can have multiple givens. So in this two-column proof right here, I have 4x minus 3 equals 13, and the reason is that's what we're given. We are given that information. Now I want you to refer to the algebraic proofs reason bank that you were given. I've got listed here the properties of equality. All of these properties of equality are what we're going to use as the reasons in the proofs for today. See those first 4 written down. Addition property of equality, subtraction property of equality, multiplication, division property of equality. All of those are what we did, okay? So when you, in this first step right here, 4x minus 3 equals 13, see how we added 3? Let me find my, right here. See how we added 3 to both sides? That would be the addition property of equality. If I had subtracted 3, it would be the subtraction property of equality. If I multiply both sides by something or divide both sides by something, that's the division property. Some other properties that you may see are the reflexive property of equality. It's just A equals A. It seems kind of redundant or ridiculous that you have to write that in a proof, but a lot of times you have to use the reflexive property to just show, okay, it's equal to itself. A equals A. Substitution property, I can substitute, if A equals B, then B can be substituted for A in any expression, right? So if x equals 5, anywhere I see x, I can substitute 5 in for x. The symmetric property, I can just switch the order. If A equals B, B equals A. Transitive property of equality. This is if A equals B and B equals C, okay, so they equal the same thing. That means A equals C. Distributive property, you've seen this, right? I can distribute the A into each term inside the parentheses. And then simplify, that's just combining like terms. So these over here are going to be what's in the left column. Those are going to be what we write in the reasons column. Okay, so let's do that. So back to our first two-column proof. 4x minus 3 equals 13. That's what we were given. The next step that I've highlighted in yellow, 4x equals 16, that's what we're gonna write in our statements column in number 2. Our reason is, what did we do to get to 4x equals 16? Well, that's what's highlighted in pink. We added 3 to both sides. That's the addition property of equality, and that's what I'm going to write down there. Addition property of equality. You also might see people just write addition property of equality, addition POE. Whatever you need to do to let you know this is the reason, the addition property of equality. Okay. The next step, what we're going to write in this statements column in number 3 is the next thing that I've highlighted in yellow, which is x equals 4. Okay, what did we do to get there? We divided both sides by 4. That's the division property of equality. I'm going to write that down there, the division property of equality. So I have what I've been given. That's what I write in statement number 1. Given is the reason. What we're asked to prove, x equals 4, that's going to be our very last statement in our proof. Let's move on. Example number 2. I've got a more difficult algebraic equation. Let's solve it. Okay, I'm going to write that down here. Solve and show your work. You can pause this video at any time. So 2 times 5x plus 8 minus 3 equals 4x minus 17. I need to get rid of those parentheses, so I'm going to distribute the 2 into each term inside the parentheses. 2 times 5x is 10x. 2 times 8 is 16. So I get 10x plus 16 minus 3 equals 4x minus 17. I'm going to combine like terms on the left side of that equal sign. 16 and negative 3 is 13. So I get 10x plus 13 equals 4x minus 17. Now I need to move my variables to one side. I'm going to subtract 4x from both sides of the equation. I'm left with 6x plus 13 equals negative 17. So that eliminated that 4x on the right side of the equation. Now I need to move my constant to the other side. So I'm going to subtract 13 from both sides, and I'm left with 6x equals negative 30. Now I need to divide both sides by 6, and I'm left with x equals negative 5. So I've shown my work here. I've essentially done an algebraic proof, but we're going to do our two-column proof where we write our statements in the left and our reasons in the right. Again, every single step with an equal sign is what we're going to use as our statement. Our reasons, we're going to refer to that algebraic reason bank, or that algebraic proofs reason bank. So the first thing I have is 2 times, I have what we're given, right? So I'm going to write that. That's already filled in my statements column. And then given is in the reasons column. And as you can see, some steps in the statements column and the reasons column are given to you. And that's just to help you through the process. Okay, next step. All right, well, we got 10x plus 16 minus 3 equals 4x minus 17. What did we do to get there? We distributed that 2 into each term inside the parentheses. Okay, so the next thing I've highlighted is 10x plus 16 minus 3 equals 4x minus 17. That's what I'm going to write there. In the reasons column, what did I do to get there? Let's go to our algebraic proofs reason bank. I use the distributive property, and that's what I write there. Again, pause the video if you need to. The next step, I need to combine like terms to get to the next step, which is 10x plus 13 equals 4x minus 17. And I have that already written down there. So 10x plus 13 equals 4x minus 17. What did I do to get to that? I combined like terms. I'm going to write simplify as my reason. Okay. If you're confused, it's quite all right. It's very normal. The way you get better at proofs is by doing them. Okay, next step. I'm gonna move the variables to one side, right? So minus 4x from both sides to get to 6x plus 13 equals negative 17. And notice I highlighted what I did, which was subtracting 4x to both sides, in a different color. And then the equal sign, or the step with the equal sign in it, I highlighted in yellow. I'm going to write what I highlighted in yellow in spot number 4. 6x plus 13 equals negative 17. What I did to get there is in pink. What did I do? I used the subtraction property of equality, which is already written down there. Next step, I subtracted 13 from both sides to get 6x equals negative 30. I've got that already written down in the statements column. 6x equals negative 30. What did I do to get there? I subtracted 13 from both sides. So again, that's the subtraction property of equality. Next step, I'm dividing both sides by 6 to get x equals negative 5. I'm going to write, what am I going to write in that statements column? X equals negative 5. What did I do to get there? What did I do to the previous equation, 6x equals negative 30, to get to x equals negative 5? I used the division property of equality. I'm going to write that down. So what we're given is right here. That's our first statement with given as our reason. What we're asked to prove, x equals negative 5, that's always going to be your last statement. So the whole process is going to have steps and reasons that go along with it. All of your steps are your equal sign, right? Your solution process, your lines with an equal sign. And then what you did to get to that point. All right, let's move on to example number 3, which is more difficult, or it seems more difficult, but let's work our way through it. Okay, so you're given that the measure of angle ABC, okay, that's the entire, let me get my mouse over here. That's ABC, that's the entire angle. Both of these angles together, I would get 8x plus 9. ABD, angle ABD is 6x plus 1, and the measure of angle CBD is 3x minus 4. Okay, so if I added both of these two angles together, I would get that entire angle, right? Which is 8x plus 9. Oh, yep, that's the angle addition postulate. Okay, so let's move on. I'm going to write that down here. The measure of angle ABD plus the measure of angle DBC is the measure of angle ABC. I'm sorry, I think I forgot to mention what we're asked to prove. We're asked to prove that x equals 12. Okay, so I need to set up some type of equation and solve for the value of x. Okay, I'm given angle measures, so let's set up an equation using these angle measures. I know the angle addition postulate says that if I add these two angles together, I'll get the measure of the entire angle. I can use substitution and plug in those expressions. I know 6x plus 1 represents the measure of angle ABD. 3x minus 4 represents the measure of angle DBC. And 8x plus 9 represents the entire angle measure. So now I have my algebraic equation. You need one algebraic equation when you have one variable to solve for the value of that variable. So I've written that equation. So now we just need to solve it. What do I do first? Well, I'm going to combine like terms on the left side. 6x plus 3x is 9x. 1 and negative 4 is negative 3. So I get 9x minus 3 equals 8x plus 9. Now, let's move our variables to one side, constants to the other. I'm going to subtract 8x from both sides to get x minus 3 equals 9. Then I'm going to add 3 to both sides to get x equals 12. And there's my solution. Okay, now let's fill out this two-column proofs table? Well, I have the measure of angle ABC equals 8x plus 9. That's one thing that we're given, right? I have the other things that we're given as reason number 2, and I've got given as the reasons for both. You might see in a proofs table, you might see all the givens written in just statement number 1, right? Every given written right next to one another. You might see the given statements written as like number 1, then it might be written as number 5, whenever you apply it. And that's totally fine too. We'll do some examples like that. But I've got my statements or my given statements written in there. Okay, moving along through this more difficult one. You can see number 3, I have the angle addition postulate as the reason, and I've already written that there, which states that the measure of angle ABC plus the measure of angle DBC equals the measure of angle ABC. So I have to show that I'm using the angle addition postulate, and here is what it is saying to solve this equation. Okay, that's the very first thing that we wrote. What did I do in the next step? To get 6x plus 1 plus 3x minus 4 equals 8x plus 9. What did I do to get there? I used the substitution property, right? We know we were given that the measure of angle ABD right here is 6x plus 1. I've already defined it right here, so I'm going to replace it right there. I've already shown that CBD, which is also DBC, same angle, is 3x minus 4. I've written that there. And ABC is 8x plus 9. I've already shown that there, so I can replace it right here. So we use the substitution property. Okay, the next thing that we did, what did we do? Well, we combined 6x and 3x to get 9x. We combined 1 and negative 4 to get negative 3. And I was left with 9x minus 3 equals 8x plus 9. I'm going to write that down. What did we do to get there? We combined like terms. Our reason is we simplified it, right? Let's just combine like terms. Okay, next step. We subtracted 8x from both sides to get x minus 3 equals 9. I've already got x minus 3 equals 9 written down as my statement in slot number 6. What did I do to get there? I used the subtraction property of equality, right? I subtracted 8x from both sides. So I'm going to write that down. Subtraction property of equality. Now to get x all by itself, I'm going to add 3 to both sides to get x equals 12. X equals 12 is my final statement. What did I do to get there? I added 3 to both sides. That's the addition property of equality. So let's write that down. So again, you've got what you're given. Those are the first things that you write down with given as your reason. This is what we know. What you're asked to prove is your last statement. All of your reasons, you're going to refer to that Algebraic Proofs reason bank. That's what you're doing, right? Those are your reasons, what you did to your equation to get the variable all by itself. Okay, let's move on to example number 4. This is our last full proof. Example number 4. We are given that the length of segment AC is 11x plus 10. That's here to here. 11x plus 10. That's what we're given. We're also given that the length of segment AB is 4x, and the length of segment BC is 8x plus 3. We're asked to prove that x equals 7. Okay, I know that when I am given all these expressions and I'm asked to prove that x equals 7, like this is the value of the variable, I've got to set up an equation. How am I going to do that? I'm going to use the segment addition postulate, which states that if I add segment A, the length of segment AB to the length of segment BC, I'm going to get the length of the entire thing. And here's how I might write that, right? AB plus BC equals AC. Then I'm going to substitute the expressions in for those lengths. So the length of AB is 4x, and the length of BC is 8x plus 3, and the length of the entire thing is 11x plus 10. So I just substituted that in. And now we've got our equation with one variable. Let's solve the equation. I need to simplify the left side of the equation. 4x plus 8x is 12x. So I get 12x plus 3 equals 11x plus 1. I need to move my variables to one side and constants to the other. So I'm going to subtract 11x from both sides to get x plus 3 equals 10. Then I'm going to subtract 3 from both sides to get x equals 7. So now let's fill out our two-column proof. What goes in that first statement? What am I going to write there? I'm going to write the length of AC is 11x plus 10 with given as the reason. And then in number 2, it's already written there for you. What is that? That's also what we've been given. So what am I going to write as the reason given? Then number 3 is already written out for you. That was what we did right here. We just stated that if I add the length of AB plus the length of segment BC, I get the length of the entire segment AC. And that is the segment addition postulate. So here we have like what we wrote down, and here's the why. We use the segment addition postulate. Okay. Our next step was we substituted in the expressions in for like the length of AB, the length of BC, and the length of AC. And I've got my little Algebraic Proofs reason bank. If you can see it, refer to that paper. Hopefully you have it in front of you. So I've got, again, I highlighted my line with an equal sign in it, right? The statement with an equal sign. I highlighted that in yellow. That's what goes in your statements column. So I'm going to write that down. 4x plus 8x plus 3 equals 11x plus 10. And I use the substitution property. Okay. What did I do next? I combined like terms, right? 4x plus 8x to get 12x plus 3 equals 11x plus 10. I'm going to write that down. 12x plus 3 equals 11x plus 10. What did we do? We combined like terms. What do I write there as the reason? Simplify. Next step. I subtracted 11x from both sides to get x plus 3 equals 10. What do I write in the statements column in slot number 6? X plus 3 equals 10. What did I do to get from step 5 to step 6? I did what I highlighted in pink there, right? I subtracted 11x from both sides. What is that? That's the subtraction property of equality, and that's what I write down there. Subtraction property of equality, subtraction POE. Next step, I'm going to subtract 3 to both sides, and I get x equals 7. What I highlighted in yellow, that's what I write down in slot number 7. What did I do to get there? Which is x equals 7. What did I do to get there? Well, what's highlighted in pink? I subtracted 3 from both sides. So again, that's the subtraction property of equality. So we use the angle addition postulate in example number 3 and the segment addition postulate in example number 4. In anything that you're going to do today, I'm going to give you that information. If it's a segment addition or angle addition postulate, everything else, everything that you're going to use is in your Algebraic Proofs reason bank. It's that page that you've been given. But let's just recap number 4. What we were given here, the length of AC is 11x plus 10. That's a statement with given as the reason. AB equals 4x and BC equals 8x plus 3. That's a statement given as the reason. What we're asked to prove, x equals 7, that's the very last statement in our two-column proof. And then everything in between was just our solution process. each and every little step written down with the reason. Which property of equality did we use to solve that algebraic equation? So now let's talk about properties of equality and congruence. So the symmetric, reflexive, and transitive properties of equality have corresponding properties of congruence. So on your little page, you have which let me see if I can write it. Here's the reflexive property, here's the symmetric property, and here's the transitive property. Okay, so I can say the reflexive property that A equals A. The reflexive property of congruence says that segment AB is congruent to segment AB, right? So that would be a reflexive property of congruence. The symmetric property of congruence down here, that states that if angle 2 is congruent to angle 3, then angle 3 is congruent to angle 2. So I might be, instead of an equal sign, I've got a congruent symbol, right? So I know that angle measures and segment lengths are equal, but segments and angles are congruent, right? So let's go through, and the transitive property of congruence, I'll first just go ahead and read what this is. It says if segment AB is congruent to segment CD and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. Okay, so you can refer to this page to see just how the properties of equality and properties of congruence are different, right? So we're going to, in example number 5, I've got 4 little examples within this, and we're going to identify the property that justifies each statement, okay? A says angle 4 is congruent to angle 5, and angle 5 is congruent to angle 6, so angle 4 is congruent to angle 6. Well, first off, would that be a property of equality, or would that be a property of congruence? I've cut a congruent sign in there, so it's going to be a property of congruence. What is it? It is the transitive property of congruence. We'll write that down. In example B, it says the measure of angle 1 equals the measure of angle 1. Is that a property of equality or congruence? It's a property of equality. Which property? The reflexive property. So it's the reflexive property of equality. Example C, it says angle 1 is congruent to angle 1. Property of congruence. Which one? The reflexive property of congruence. So see how those two, example B has an equal sign, it's a property of equality. Example C has a congruent sign, it's a property of congruence. Last one, D. Angle A is congruent to angle B, so angle B is congruent to angle A. Property of equality or congruence? Congruence. Which property? Symmetric. Symmetric property of congruence. And that concludes today's notes over algebraic proofs. I know it was long, but I hope it was helpful.